to make sure that we talk about, actually I should show this real quick, to make sure that we talk about that tomorrow's recording is also going to be used in the afternoon, kind of just like yesterday, so we need to kind of try to keep side noise to a minimum. Today's homework is due next week, right? Same with yesterday's homework as we talked about, not yesterday, Tuesday, but next week, Tuesday. But today, your 521, 522, and 523 are due, so please turn those in by the end of the day. And your header, for those of you who want to know, and that should be everyone, probability trees.
Oh. Are we putting this on our blank piece of paper?
Both of them, really, because we're going to use both for this stuff. The blank piece of paper was so that I could save paper being used by like a copy machine or whatever, because that paper, if you flip it over and look at it, comes every time I make a set of copies, they send that paper with it. It's like a title page. And I think that's a giant waste of paper. Just think about how many sets of copies I make through the year.
A lot. This one just says, this one doesn't even have anything on it.
2 pages. That's page 2 of what comes with as the header page. So here, look. Look. Case in point. I just picked up a set of copies. They're blue, but on top of those blue papers, or this paper, that tells you what it is, and then this nonsense paper that doesn't do anything. Yeah, so that's the paper we're using up as blank paper.
Mr. Beast doesn't support.
And Mr. Beast. All right, Maria, what problem?
It's on 5.2.2.
Oh, a previous one. So what's the problem number still?
5-42.
So what's your question?
When I graphed it, it was kind of like awkward, and some were like.
Do you have it that I can look at?
And half of them was complicated, so I didn't know how to find it.
Oh, that's not a bad shape. Wait, can I show this? Do you care?
Yeah, no, I did not.
So now wait a minute. Oh, you graphed the negative direction going the opposite way. Now remember, negative has to go left, positive has to go right. So you flipped your axis, which is okay. Your shape just looks like it's reflected, so actually I'm a little scared to show that. When you get, I'm still going to talk about this, but when you get a shape that looks like a rectangle that has been grabbed and like stretched sideways or pulled sideways, that's a parallelogram. So if you can imagine, you took a rectangle and yanked it sideways so that both of the sides of it do the same thing. The area of this shape is the base times the height, when the height is how tall it is. So Araya, what you want to do there is figure out what is this length, and you can count that on your graph. And actually, you can use what you drew. Just know that in the future, you got to flip your negative to the left side. And this is your height. Do not fall in the trap of using this. That's not your height. That's what we call your slant height, actually. It's your essence. It's your slant height. Anybody else need these? I'm moving them over here because I want a place to sit. Other questions from other homeworks? Other questions from other homeworks? How long could I wait before it gets awkward?
Not too long. 12 years. Expect us to sit here for 12 years.
Yes.
Before it gets awkward? That's a long time. All right. So, anyone want to go get ice cream?
Yeah.
So do I, but sadly, the best I have is you. So, offensive. All I did was ask you if you want ice cream. So,
But then you just took it back.
has anyone ever been to Cookie Dough Creamery?
Yeah.
By the way, I didn't say let's go get ice cream. I just said who would want to. I'm just asking questions. Don't be mad at me. We're all friends here. I want to go get ice cream too. Should I be mad that you're not taking me? No.
Well, let's go to Dairy Queen.
Legally, I can't take you.
Okay.
Okay. So,
Who said anything about being legal?
Olivia, you said you've been to Cookie Dough Creamery. Explain to us the choices that you make at Cookie Dough Creamery.
Well, you choose the size of cup you want, and then you choose the kind of cookie dough you want, and then you choose the kind of ice cream you want, and then you choose the kind of topping you want.
It's a lot of choices. So if we think about yesterday's work that we did, and actually we've had some people sick and we've had some people miss classes. What did we do yesterday? What diagram did we use to help us solve problems? Nick?
Probability table.
Tell us more. What's a probability table?
So it's kind of like a generic rectangle. Like, what's that thing called? It's easier, for math.
Easier for math.
12 times 19, but instead of doing
Oh,
it straight.
multiplication table?
Yeah. No, it's like a
Sort of.
10.
So it was like your old multiplication tables, but here we added because we were looking at the results. Right? So as Nick was telling us yesterday, we did this probability table, but this was only good for 2 events. Right? What Olivia just described about getting ice cream, are there 2 events there? There's a lot more than 2, right? So probability tables won't work when there's more than 2 events. Hence, today's lesson is probability trees. So before we go to get ice cream, let's go play double spin real quick, just to make sure that we remember how to build a probability table, and then we'll extend it to our probability trees. So we go to the carnival, and it's kind of a weird carnival. They have like math-related games. Just don't. I sponsored this carnival. It's all good. So we have this spinner. It's called the integer double spin.
Oh.
I got some people I think off topic / sketching. Please come back to me. So when we think about playing this game, we have these results: -2, -1, 0, 1, and 3. And we're gonna spin it twice. What does sum mean? It says the sum. Morgan, what's sum? Ooh, that's product. I know, these are weird words. Toby? It's the answer to an addition problem, so we're going to add. So, work with your team to determine the probabilities of the different outcomes. Are each of these pie pieces like the same size? Each of the slices of the circle?
Looks like it.
Yeah, it looks like it. We can infer. There's no like trickery going on here about one's bigger than the other. These are all equal. Let's assume it's divided up equally. Oh yeah, they said equal up there also. So, if we think yesterday about Gerald, right? He listed out like a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1. Was that the best way to list out our sums? No. So instead, and because I like you guys, we're not going to make a list. We're going to jump right on down to here. Let's draw another square on your paper, and we're going to use a probability table to talk about these sums and these possible outcomes. Yes. Sorry, I'll tell you when we're using your blank paper. Sorry, this is still square. So graph paper makes sense to draw like vertical and horizontal lines. I put my numbers in order just because I like it that way. You don't have to, but then yours won't match mine. So I would encourage you to match mine to make your life easy. So then we're also going to go in the same order on the other side. And we're going to split up our table. And then fill in your table with the sums. Remember, we're adding. So like -2 and -2 makes a -4. Whereas like 3 and 3 make a 6. Right? So I'm going to walk around and help anyone that needs help. Yeah, some of you are probably learning making your probability tables too small makes it a little difficult. So as you set these things up, give yourself enough space. Why did this get printed? I was just curious because I saw that you had an email. I email and ask for recycling to get taken out. Yes, that is a thing I do.
I got your billing charge
Did
code.
you steal these?
No, no.
I'm pretty sure you took them out of my closet.
I promise. Across my heart. You can ask me.
Look at this. Same exact package.
No, I promise. I swear. Across my
I'm
heart.
just teasing.
Across my heart.
I got your billing because you're easy to mess with.
Excuse me?
Well, actually, you actually stood your ground pretty well. You said like, no, these are mine. These are mine.
I have a receipt.
I have the evidence. So we go fill it in. Be careful. There's a little bit of jump because we go -4, -3, -2, -1, but then we jump over the 0 straight to +1, right? Because there is a gap right here. There's no 2, right? Our spinner's missing a 2. They jumped it right up to a 3. So be careful. There's a gap right there. Same over here. -3, -2, -1, +1. Fill in your whole table, please. I got some people waiting for me. Please don't wait for me. Turn your brain on. Guys, this yogurt is supposed to taste like cookies and milk. And I'll tell you what, it's a pretty good fake.
Is it healthier than
It is. It's Greek yogurt.
Oh.
Yeah.
have Greek coffee.
Wait a minute. The -4's on its own. The -3's run diagonal. The -2's run diagonal. The -1's run diagonal. Do the +1's run diagonal? What goes here? Oh, this is a 0. And this is a 0. And this is a 0. Guys, be careful with that middle diagonal. The jump there and there create this weird, like this is kind of on its own out here. And this is on its own because that jump in our numbers created this odd little switch. And then +3, -1. Okay, that's +2. 1. And, ooh, this is weird also. 1 and 0. 1. These are all goofy. 3 and 0. 3, 1, 2, 3.
Whoa.
4. 4. So guys, be careful. This table's not like our dice table yesterday because there's a weird gap here.
Just because I have one gap makes a big difference.
I mean, when we lay it out on the table. So then if Tabitha could choose winning the sum for double spin game, what sum would you advise her to choose? So if you walk up to the game, and again, I said this is like the weirdest carnival ever, and they're like, welcome to double spin. You choose how you win. You're like, wait, what? You have to pick what would make you win. So turn to your partner and decide, of course, this is when I'm going to pull out random cards here in a minute. What number would you choose? Or what number would you choose to make the other person if you want like somebody else to lose? So essentially, what's your best probability? What's your worst probability? Sorry, I'll just ask the questions directly. What's your best probability? What's your worst probability?
-1 or no, or -1 or 0. -1
No, but there's also no, -1 has
Okay.
no, the one in the corner.
Oh yeah, there's 4
And then there's also 4 negative.
Okay, so is there positive or negative 1? And then the worst is -4.
Yeah.
Oh, I meant to grab the card stack. That's what I was doing. That would help.
Okay.
Sorry.
See how many?
You are deep. You're deep in here. When I get back to here, I'll shuffle. Lose, what did you guys think had the best probability here? Sorry, you said what? Or, I know what you were answering. So you said -4 or 6. What probability was that? Best or worst? That was the worst, right? So if we look at the probability of a 4 or a -4 or a 6, they're tied, right? They're gonna have the same probability. So that's 1 out of 25 here, 'cause it's a 5 by 5. Please write this down, just practicing. By the way, guys, we are having a quiz on Friday, in case I breezed over that information. It will be on the percent models. Sorry, I wrote down I still have to make it. It'll be on the percent diagrams, like those bars where we separated out how many percent are in this section, and then what number goes on top, how many percent are in this section, what number goes on top, and it'll be over probability diagrams. So probability tables and then probability trees that we're going to be doing today will be on the quiz Friday. The mini mastery. Yeah. Unacceptable. You must come to class and take this mastery.
Or else he will break into your house and force you to take it while
I mean, you can take Math 7 again. That's an option.
I have to go to Cincinnati to get my braces off.
You're going to Nasty Natty instead of my math class?
Cincinnati is amazing.
I'm joking. I do love Cincinnati. It's
Oh
just
my
for some
God,
reason
this
it
is
has that
recording.
nickname.
This is
Okay,
great.
so you're fine. I will try to have it made by tomorrow. If you have the chance during AO extensions tomorrow, come grab it and try to take it for me. Otherwise, Tuesday. Or if I have it made by tomorrow, I might let you take it from me.
Orthodontist in Cincinnati.
Because she gets it for free
Might
from
be
her uncle.
Because I can trust you not to cheat, right? Cool.
It's so funny.
All right,
I will video
so,
Unacceptable.
especially because I can't resist the temptation from like sarcastically responding, please don't do that to teachers in the middle of class. I know that's probably when you thought of it and you're like, oh, I need to say this before I forget, but try to come to us outside of class to talk about those things. You're good. No issue, because we don't do a good job talking to you guys about that, but we all want to make sure we take care of you. So like, I respond to you, I give you that time in the moment, but everyone else is just like sitting here, right? So the best, Meredith, thank you for volunteering, the best probability here is what number?
-1.
Yeah? I mean, you had a question mark on it, so let's check. -1, there's 4 of them.
Yeah.
Is there any other number up there that has more than 4?
Yes.
What number?
Yes. It is 1. Or not more than 4, it's equal to.
Oh, 1, 1, 1, 1. Any other number up there a lot of times? I don't think so.
I wasn't wrong.
We have 2, 2, 2. Yeah, and then the other ones are negative. So I think either a -1 or a +1, right? So what is that probability? If I choose +1, that's 4 out of 25. So anything you choose here is pretty tough to win.
This game is rigged. Like most carnival games.
It's rigged. I don't know that it's rigged. You get to choose what wins.
But, like, 4
Now,
out of
if
25.
you okay, so talk about that. What do you mean? 4 out of 25? Like you're complaining. Why are you saying this is quote unquote rigged?
Because like you don't have an equal chance. The best chance, you only have like a 16% chance of winning.
Yeah, guys, this Zach went ahead and did the math. If I put this over 100, that's 16 over 100. That's 16% chance you'll. So you pay $1, $2, whatever the game costs, for a 16% chance at winning. You're betting 84% chance that you'll lose. Right? That's an 84% chance that you'll lose. So it's not necessarily rigged, but it's stacked against you. Right? The probability is against you. All right, now we're going to get ice cream. Not actually. Not actually.
Can't.
You're hurting my feelings.
Let's get a good hockey story
You're
there.
making me have trust with a laser pointer.
I used to get free ice cream.
You're like sitting in your therapist's office and you're like, my math teacher lied to me in 7th grade, and ever since then I've just had trust issues.
One time in 7th grade, my math teacher lied about taking me to get ice cream.
So pull out that blank sheet of paper. That blank sheet of paper.
I'm just going to get some ice cream and eat it in front of you.
I have popsicles in the office. Don't make me go get one.
Every time somebody says
Anyone need a sheet? Anyone not have it? Got you. I know the math has stuff on it, but that does not matter. Anyone else? Anyone else? Anyone else?
What if you like buy $100
All right. So Scott just got a job at an ice cream store. Now, Scott, can I like make it stories, or do we just have to just do that? Let me make it a story. So Scott's trying to help this ice cream store with their advertising, and he thinks it would help to tell their people coming to the store like, we have this many options. Like, have you ever been to like an ice? Or actually, I think there's pizza places with these commercial stuff. They're like over 1 million combinations possible. So Scott wants to do that with the ice cream store. So his manager's like, hey Scott, you like know some probability stuff, right? Can you figure out how many possible ice cream combinations there are? And he's like, yeah, perfect. I'll use a probability table. And he sets it up, and don't do this. So he sets up the probability table, and across the top he's gonna go flavor, right? Flavor of ice cream. Across the left side, he's gonna go mix in. No, please do not write this. And then fruit swirl. Crap.
Triangle.
So if I do this, I can talk about the two flavors and mix-ins, but what about my swirl? I don't. Crap. Darn it, we talked about this yesterday. I can't use a table for more than 2 things, because a table only goes 2 directions. We could do a 3D model. So give me your eyes. Imagine this. Ice cream flavor, mix in, fruit swirl. Right? We could do a 3. Now it would be a probability cube. Don't. Keith Morgan, stop. Come back from that ledge. Since we can't draw in 3 dimensions, now if you want to go model it in Blender, that's up to you. But since we can't draw in 3 dimensions, Scott's coworker is like, oh, dude, I learned something in math that was better than probability tables. It's called a probability tree. What we can do with this is talk about as many choices as you want. So a probability tree, please have this at the top of your paper, or somewhere you can write it again if you want. A probability tree will show all the different probabilities branching off each other. So you don't have to write that like exactly, but it can work, bless you, it can work out to the side, or it can come down like the roots of a tree, and that's why we call it a probability tree. So actually, we're going to have it, if we turn your paper sideways, we could come down. I guess we can do this one like this, and then I can let you make your choices. Your paper is probably tall, like vertical. So if we start making this probability tree, we always have a start that isn't really like labeled with anything. We just start at a point. The first choice is flavor of ice cream, right? So you don't have to write flavor, but what we do have to write is chocolate and vanilla. This is on the blank. I already said the blank paper, so you can draw diagonal lines. Now, sorry, I should have said this. You want this to be like in the middle of your page. Sorry, at least you didn't get too far into it. You want this to be like in the middle of your page, because we're going to keep branching both directions. Ours, it will eventually look like this in a way. It will be that big. To the left of your paper? Yeah, put this like at the left of your paper in the middle. Ah, I see what you mean. So you want this to be like here, where you put start. It's okay if it's not, but I'm just hoping you're sure you can. After you choose your flavor, let's say he chose chocolate, you get to choose a mix-in. The mix-ins, hazelnut, sprinkles, and toffee bits. So we have hazelnut, sprinkles, and toffee bits. Now, this tree is assuming you only get one of each. One choice of each, no stacking on like crazy. The parents said one choice of each. So then we get a flavor swirl that is apricot, plum, berry, or grape. And we're going to abbreviate those with apricot, plum, berry, and grape. So if I look at this possible combination, that is chocolate, hazelnut, and grape. Gross. Now hold on. Shh, hold on. You have to fill in the entire table. So if we go choose sprinkles, hey, apricot, pear, berry, grape. Apricot, pear, berry, grape.
Wait, wasn't the pea plum?
Sure, probably.
Oh, okay.
Or peach, or pineapple, or I don't know. Something like that.
Yeah, pineapple.
There's my one mistake for today, I guess. I'm joking. I make a lot of mistakes. Hazelnut sprinkles toffee. Sometimes if you don't leave yourself enough space, you just have to bring your table down. You know what I mean? I didn't really leave enough space, so the top of my table fits right there, or the top of my tree, but then the vanilla part of my tree needs its own space down here. So then we have apricot, plum, berry, grape, apricot, plum, berry, grape. So if we look at all of the options, there are 4 options off of toffee, 4 options off of sprinkles, 4 options off of hazelnut, but each of those come from 2 different flavor options first. Here's the convenient thing about the probability tree. When we're talking about the denominator, like the probability of something happening, the denominator is just everything at the very bottom of the tree or the very end of the tree. So we want to count how many do we have out here of the A, P, B, G, like so 4, 8, 12, another 4, 8, 12. So how many do we have total out here?
32.
Ooh, close. We do not count these in blue because, guys, the hazelnut is out here in the chocolate hazelnut grape. So Scott's sister trusts him too much.
Oh, no.
Scott's sister, as he was leaving to go to the ice cream shop, says, "Hey Scott, pick me up some ice cream, choose whatever you want." So Scott tells the person behind the counter, just randomly choose whatever you feel like. What is the probability that Scott's sister ends up with the chocolate hazelnut grape ice cream?
Oh, good Lord.
1 out of 24, right? There are 24 possible ice cream options. Some of you are thinking very maniacally right now. You're like, "Oh, I would love to do this to my sibling, Zach."
I'm the younger sibling, so my sister would do that.
Which is approximately, hey. This is approximately 4%. Because if I multiplied by 4, I could get to 96 on bottom. That's approximately 4%. So she's got like a 4% chance of ending up with that gross ice cream combination. Does that alarm is for you, Sarah. Does that make sense for what we did? Could you do this on your own? Good time to show me. Oh, hold on. We got to talk about one vocab word that eventually we'll need to memorize. Guys, I wasn't joking. Scott's sister loves hazelnut, but Scott's brother loves grape. So, hold on. So, if we look to try to accommodate his sister, we got to go back and look at all hazelnut options. She doesn't care about anything but hazelnut, right? So if we go back, Zach, you're having too much fun. If we go back and look for how many hazelnut options are there, we're looking at this, right? Well, how many hazelnut options are there up here, Savannah? 4. How many hazelnut options are there total? 8. Hey guys, I got some people that I think I'm losing. Stick with me. If we look for all hazelnut options, there's 4 here for vanilla, and there's 4 up here for grape. So we could say the probability of just getting anything hazelnut.
8 out of 24.
Yeah, the probability of hazelnut is 8 out of 24. Approximately 32%. Because if we quadruple times 4 to get that close to 100, times 4. Are you going to be okay, Zach?
No.
No? Okay, well, I guess I'll call your mom now.
Okay.
Bye, Zach.
So wait, little brother loves grape. Now we can go back and find grape. What's the probability of grape here? How'd you get 6?
Well,
You're right.
because each thing has, we have HST, and each thing has G, and I just looked at all the G's, and it was 6.
Yeah.
Do math.
So guys, this probability table, tree, is really convenient for being able to just count things. The probability of getting a grape result is 6 out of 24. Now, when we talked about the chocolate hazelnut grape, or we could talk about vanilla hazelnut grape, that would make both of them happy. Vanilla hazelnut grape might not be terrible. Are you all right, man?
Which tablet?
I don't know. Don't judge people.
Wow.
So, hold up.
Now,
I need you to think.
Zach just literally just said into madness.
Mutually exclusive, which is a confusing name, like words up. Mutual means like together, right? But exclusive means not.
Contradictory.
So, mutually exclusive means these two things do not share any results in common. So, at that ice cream shop, chocolate and vanilla are mutually exclusive. You cannot mix them. They're very strict about their ice cream and their own choices. So, do Scott's sister and brother have any results in common? If not, they're mutually exclusive. So do they have any results that include both of their preferences? Yeah, we looked at one, right? The chocolate hazelnut grape looks for both of them, right? Like sister would be happy hazelnut, brother would be happy grape. No one would be happy with this though.
That's what we have.
That's gross.
All right, you ready to do one on your own? So, let's say that fog last night brings in some like a shark-nado or something, and all of a sudden we have no power. Shark-nado. Shark-nado. So you are getting dressed in the dark. Now, I don't know if you ever the shark-nado destroyed all the flashlights. I don't know if you've ever had to get dressed in the dark, or if you've ever just not cared about what you're going to wear today, but you've got like a drawer with socks and a drawer with underwear, and like you know where to reach, but you just can't see anything. So, and it's winter, it's dark outside. Hold up, you're going to need to like write this down or something. 1 shirt, 1 pair of pants. Okay, not crazy. She has 3 different pairs of pants. a black pair, a brown pair, and a plaid pair. Yeah, plaid. And she has two different shirts, a white and a polka dot. Polka. It's polka with an L.
Who says polka?
It's polka
Nobody
music.
says polka dot.
You say polka.
Polka dot, polka music, polka. On your own, draw a probability tree to organize this. I don't care if you pick your pants first or your shirt first, but I will tell you one way is easier than the other because you have less to draw. And I might as well give you that hint. If you have the choice, do the more options first. So if I was giving you advice, do pants first because there's more of them. Well, like dress pants, you know.
It's like polka dot from the Weird Al album, Running with Scissors.
So, here's the trap door that I've already seen a couple of you fall into. And I don't even know what language they're singing in. Where's polka music come from? You just said poop. What we're not writing. Sorry to break your heart for those of you that did this. We're not writing pants shirt. We're not. So if you wrote that, erase it. If you were to write pants shirt anywhere, we could write shirt out here above the split, but what goes here are the outcomes, right? So, sorry, I said do pants first? Which had 3? Pants. So if we're going to do pants first, pants have 3. That could go above the split, but we have black, brown, and plaid, right?
Yeah. I think that's for sure.
No, that's pants.
A what shirt?
Polka
Polka
dot.
shirt, right?
A polka dot.
So then,
Polka dot. That's not going away.
no, I think it's a Phoenix 2020 thing now, maybe. So you said we have white and polka dot?
Yeah.
White and polka dot. So white, polka dot. White, polka dot. White, polka dot. Now, what we didn't realize was it's actually Spirit Week, and it's actually Crazy Day. So if we had the option, we would like, it's safe here, there's a lot of cinder block. We would like to end up in the plaid pants and the polka dot shirt. What is the probability we end up in plaid and polka dot?
Zach, is this like really funny or something?
1, I think Zach's just broken today. There are 6 options out here, right? Now wait, what if I just asked you, hold on. Hey, I have a couple minutes left and some of you are making my job harder than it needs to be. If I just care about getting plaid pants, what's the probability of getting plaid pants? 1 out of 3. If I just want a polka shirt, what's my probability of just choosing a polka shirt? 1/2. Right, there's only 2 shirts. Check this out. This, give me your eyes. The probability of both things happening, the probability of and multiplies the other probabilities. Hold on, I still have a minute. So where we're headed, stop packing up. Where we are headed is going to be writing the probabilities on these stems. So we would say a third, a third, a third. We would say a half and a half, meaning that out here, a third and a half make this a sixth. That's where we're headed, especially when things don't split fair. and there's not an equal chance. Now, pack up and get out of here.
Also, my like chocolate. Oh my goodness!
There's a bad. There's at least one shark. But wait, we could make it a whole shark-nado if.
You just copy and paste it.
There we go, shark-nado. There you go. All right, get out of here.
That's real scary. I'm gonna have it down there.
What?